Now I'm hitting record. Okay, so what we're going to be looking at here, since we know these triangles are similar by angle-angle similarity, all right, if I want to write the ratio of their side lengths as far as similarity is concerned, I know that it's going to be the length, like if I go big triangle over little triangle, it's going to be x plus y over x is going to equal a plus b over b. And again, the reason why is because x belongs to this length, and if I'm comparing the triangles, right, y is actually this whole length here, or sorry, not y, this whole length here is the side that I have to consider, right, and this whole length is x plus y, okay, and it's the same thing for this side, okay. I put over b and it should be over a, and I apologize. Okay. And so that a represents that whole side, and this whole length right here is not b, it's a plus b, okay? Now when you're looking at that ratio, you're going, okay, that's really confusing, but I'm actually going to simplify this out. So if you remember when we add fractions, okay, if I'm adding fractions, we have to have common denominators. So if I want to do, like, for example, if I want to do like 1 over 2 plus, 3 over 4, right? I had to make this one 2 over 4 plus 3 over 4, and then when I add them together, it becomes 5 over 4. So I add the tops but keep the bottom the same, right? We're going to do that exact same thing, except for we're going to work backwards, okay? So this is the same thing as going, well, if I have 5 over 4, I could rewrite this as 2 over 4 plus 3 over 4, okay? So that's what I mean by going backwards, okay? So if I have x plus y over x, I can actually rewrite this as x over x plus y over x, okay? And I can do the same exact thing on this side, okay? So I can go a over a plus b over a. Now, what's something that you notice that now appears on both sides? Can anybody tell me? What's any number over itself? 1, right? So if we look over here on this side, we have x over x, and we have a over a. Okay? So what I've effectively done is turn this into 1 plus y over x is equal to 1 plus b over a. And I know you're probably going, well, this isn't making this any less complicated, right? But one of the things that you're going to see is that if I subtract 1 from both sides, what we're saying, right, is that now I have y over x is equal to b over a. What does that mean? It means if I look up here at this triangle, that's saying that y over x is equal to b over a. So now instead of having to use the entire side of the triangles, we showed that as long as these two triangles are similar, as long as this line is parallel right here, right, we effectively have a relationship, all right, where I don't have to go x plus y over x, a plus b over a. I can just do the little part over the other part. I can basically break this up into parts instead, okay? So now I'm going to do this same exact thing. Sorry, I have to draw my triangle in here really quick. Oops. Trust me, this will make sense why I'm doing this in just a minute. Okay. Now I'm going to do the exact same thing. So here I have a triangle here, and it doesn't quite look like a triangle, but you can tell that there's one in there. And I'm going to draw another parallel line. Okay? So nothing's really changed. Okay? If I look at this as, sorry, come on, like y, x, a, b. If I still look at this part, I can still write this as, well, x over y, y over x is going to equal b over a. I can still write that, okay? But how I'm going to change this is I'm going to say, you know what? Let's add this other parallel line in here, okay? And now, let's just call this z and d, okay? So what do you think is going to ultimately be true about the relationship between these guys? Again, these are all parallel. The same thing's ideally going to be true here, is we're actually going to be able to say, well, y over z is equal to b over d. And the reason that we can say that is, again, right, this is still a triangle. This is still parallel sides, right? So I can go through the exact same process, just obviously a little bit more complicated, and show the exact same kind of relationship, even if I have that this now length up here is x and this is b. I can show that, well, z over x is equal to d over a, right? But y over x plus z is equal to b over d plus a, and so on and so on. And I can just literally go through this for a long time, okay? And I can do this as many times as I need to, okay? I can literally cut this thing up into a million different parallel lines, right? And nothing's going to change. Those ratios, those relationships are still going to be the same thing, okay? So this is what we call, this idea is what we call triangle proportionality theorem, okay? But then this part that we're on right now, imagine if there was just no tip. Could we still say the exact same thing? Yeah, nothing changed. Now the only difference is we can't see the end of the triangle. That's it. So, pardon me, I'm going to try to do this. One second. I have to pull it out. Yeah. I think I do in order to get the camera show up on that side. I think I do here. I'm on that. And besides, it's for. Why are you being annoying? I hope that'll work. One sec, guys, sorry. This worked earlier this morning. There it is. So now if I go, where is the camera on this guy? Who's go? Oh, there it is. Okay. So this is kind of the notes, or the idea that we just kind of explained. So this is what we call the triangle proportionality theorem, which says if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides it into segments of proportional lengths. Okay? Basically, that just kind of means that exact same thing that we just showed. Instead of me having to go like AC over AE equals AB over AD, we can actually truncate that, and now this becomes AE over EC, right, is equal to AD over DB. So basically just kind of takes out parts of it. Now, the important thing to understand, okay, is that we didn't at once mention the bottom line, the lines that were parallel. The problem is because ED over CB will not equal this, okay? And so that's a very important distinction, right? Now, if I'm just using the idea of similar triangles, right, then I can say AC over AE is equal to ED over CB. But I can't say, hey, just this little piece over this little piece is equal to the ratio between these two, because that's never going to be true unless I'm dealing with, I think it's an equilateral triangle, right? There's literally like one case where this works, where that works. So you can't ever do that, okay? Now, I'm going to introduce this just because it kind of works both ways here, okay? So that's what the triangle proportionality says, but I can work backwards too. So if I know, right? If I know that that ratio is true, if I'm in a triangle, right? You're not going to prove this in your homework. Don't worry about this. This is old. Okay. So, so we can work conversely by saying, hey, you know what? If we have a line inside of a triangle, right, that intersects the two sides of the triangle, and it cuts it off proportionally, we can actually now prove that that line has to be parallel. Okay? So the converse of the triangle proportionality theorem lets me say that, hey, if I got this line somewhere inside of a triangle, and I show that these two, or the two segments that it cuts off are proportional, it has to be parallel. Okay? Any questions on this? Like I said, I'll be posting this, so if you don't write it down, that's okay. All right. And then the last thing I want to show that we kind of also showed is what we call proportional parts of parallel lines. So again, this is the exact same thing as the triangle proportionality theorem, but now it's just saying, hey, you know what, if we have just a bunch of parallel lines together and it intersects two transversals, I don't need to create this triangle at the top. I don't need that piece anymore, right? All I just need are the little parts that it cuts off, right? And I know that those parts are now going to be proportional. Okay? And again, it extends exactly from the triangle proportionality theorem. Okay. Are there any questions on this so far? Like I said, I will be posting these, so if you do not write them down, that's okay. I want to give you guys plenty of time to work on your assignment today. And I've got 2 more examples of stuff that we're going to go through. Okay. All right. Here we go. Oh, I really hope it doesn't show you my password. Okay. That could have been super awkward. All right. There we go. No, that was the whiteboard. There we go. All right. So kind of how... Nope, that's the wrong one. So how we can use these and how we can use this idea by using the triangle proportionality theorem. So let's just say I want to find the missing length indicated in these triangle. All right. So if I'm so again, just understanding that this side, hold on, where's my thing? All right, that the side that's 2 is just this tiny little side over here. So what we're really asking for is we're just trying to find what that other tiny little side is. Okay. So using the triangle proportionality theorem, all right, this allows us to say, hey, you know what? I know the ratio between 2 and 10, same side, has got to equal the ratio between question mark and 25. Okay. So, yes. What's up? Okay. Like I said, you'll have the video so you can take the notes like online. You're just going to have to watch them at home if you need to rewrite this, okay? All right. So I always recommend, and you don't have to in this case, but I always recommend simplifying as much as possible before I start doing the cross product. So now I've got this 2 over 10. I know that simplifies down to 1/5, which is equal to question mark over 25. And now I can use my cross product property to solve it. And so what I'm left with is 1 times 25, so 25 is equal to 5 times question mark. Divide both sides by 5, right? And I got 5 is equal to question mark. So essentially, this side right here is 5. Okay? Any questions on that? And it's going to work the same way for proportional parts. Just sometimes I might have a little bit more complicated. So for in this case, if I'm going to use the parallel lines, right? I can set it up much the same way, and I know that 10 to 8 is going to equal question mark 2. And now most of you want to write 27 down here, but that's not what this actual length is it? I'm going to use that ratio. What's the length? What's the length of just this piece right here?
8.
Why do you get 8? Can anyone guess? This is when it gets a little bit more complicated. It's 27 minus whatever the length of the question mark is. Okay. So minus the length of the question mark. All right. Again, we want to simplify first. And so this is going to be 10 to 8 is the same thing as 5 to 4 is going to equal question mark over 27 minus question mark. And I know you're going, oh, this looks super complicated, but trust me, all you have to do is the same process. Simplify, cross product property, and then solve. So if I use the cross product property, this is 4 times question mark is going to equal 5 times 27 minus question mark. So what do I have to do on the right hand side first before I can do anything? What? 5 times 27, and I have to distribute. Yep, I have to distribute. So I have to go 5 times 27 and 5 times negative question mark. Okay? So what I'm left with is 4 times question mark is equal to 27 times 5, which I actually need a calculator for that. 135 minus 5 times question mark. Okay? Now again, we're kind of treating this just like a variable, so I'm going to actually add 5 times question mark to both sides. Right? And I get that this is 9 times question mark is equal to 135. Divide both sides by 9. And I get a question mark is equal to 15. Okay? Again, this is just kind of one way that I can do this. Okay? I could actually, and hopefully what I kind of was hoping you guys saw, is I can actually go 10 to 18 is going to equal question mark to 27. All right, it's still going to break it up proportionally. It's just like the triangle inequality theorem. And that might even help you out a little bit easier, but I like to do it this way, right, because it's consistent. Right, it's the exact same way every single time. Nothing's going to change. The only thing that changes is what my picture looks like. But the steps that I take, all the process that I go through is always going to be the same. Okay? Let's look at number 3. Okay. Again, what I want to do is I want to say, okay, what am I trying to solve for? I'm trying to solve for x in this case. Now, using the triangle proportionality theorem, I know that 2 to x plus 1 has got to equal 1 to what length? Is it 5? What is it? It's 4, right? Because if this little piece is 1, the whole length is 5. That makes this little piece 4. Okay. Now from here, right, I can't really simplify anymore, but now I want to use my cross product property, and so I'm left with 4 times 2, which is 8, is equal to 1 times x plus 1, so it's just simply x plus 1. Subtract 1, x is equal to 7. Right. Does that make sense? Okay. Again, and I kind of wanted to do this so I can show you that it works the same. Even if I don't do it that way, I can still use using similar triangles. So this one was using triangle proportionality. This other way that I'm going to show you is using similar triangles. Right? In order to use similar triangles, right, instead of going 2 to x plus 1, it would be 2 to x plus 1 plus 2, because this whole side length here would be x plus 3, okay, would equal 1 over 5. Okay? Doing cross product property again gives me 10 is equal to x plus 3 minus 3 minus 3, and I still get x is equal to 7 no matter what. So whichever one I use, right, can actually get me the same solution. Okay? So it doesn't really matter. All right. Last example we're going to do. Okay? Again, we don't have triangles, we have parallel lines, so I'm just going to set it up using the same way I did before. All right, I'm going to go 35 over 10 plus 2x is going to equal 20 over 16. Okay. Now, before I move on, I want to simplify. I can't really simplify on the left, so this is still going to be 35 over 10 plus 2x. But 20 over 16, they're both divisible by 4. So this becomes 5 over 4. Again, a lot more easy to multiply here. Cross product. I'm left with 35 times 4, which is 140, is equal to 5. 5 times 10 plus 2x. Now we got to distribute. 140 is equal to 50 plus 10x minus 50 minus 50. 90 is equal to 10x. 5 by 10 divided by 10. X is equal to 9. Okay. Pretty straightforward. Again, as long as I apply the same properties, apply the same rules, right? It makes it much easier, and it's the same steps every single time. Okay. All right. Are there any questions? Yeah. Yeah. What did I put the 15? So because that was, oh shoot. Haha, thank you. That 15 is actually wrong. The question mark length is 15. Thank you for pointing that out. That length is actually 15. Right, because that's where the question mark is, and I apologize for putting it in the wrong spot. Any other questions? Okay. So you guys have the assignment for today. It's already published on Canvas. Oh, I did not publish the module yet, did I? I will be publishing that in just a moment. I apologize. And then you guys can go ahead and start the assignment. I will be posting the video as well as the notes on there momentarily. Okay?